Let's learn some application of rational functions. A linear model for a cost function for a business manufacturer of X items. Let's say the cost function is a linear function of X number of items. So X is number of items which we are producing. M is the variable cost to produce one item. B is the fixed cost. We have covered this before also, that cost of producing is the variable cost plus the fixed cost. In this case, the fixed cost is B and the variable cost per unit is M. So X number of units, this will be M times X. The average cost is defined as C bar X. The notation uses C of X but with a bar on top per item manufactured in sum total of all costs, variable plus fixed, divided by the total number of items produced, which is X. So this is the formula which you need to remember. This is average cost of production per item, C bar X, average cost per item. Average cost item will decrease as more items are produced because the fixed cost will be distributed over greater number of items. So more production happens, the average cost decreases. Okay, let's do this example. A cleaning service cleans homes. Each house calls. The cost to company is approximately $40 for cleaning supplies, gasoline, and labor. Okay, so the business also has fixed monthly cost of $300 from phone services, advertising, and depreciation of the vehicle. Write the cost function to represent C of X in dollars for X house calls per month. So we have to write cost function for 1 month. Now cost function is equal to variable cost plus fixed cost, where X is number of houses cleaned. Now they are saying the cost to company is approximately $40 for cleaning supplies, gasoline, and labor. The business also has fixed monthly cost of $300. So for each house, this we have to be noted, for each house the cost of the supplies is $40. So the variable cost M is given to be $40 per house, right? So the cost function would be, we are cleaning X number of houses. One house takes $40 to buy all the cleaning supplies. So 40 times X would be the variable cost plus $300 every month for the phone services, advertising, and depreciations of the vehicle. This is your cost function. Write the average cost function that represents the cost, average cost for X number of house calls per month. So we define average cost is equal to, it's written as Cx with the bar on top. So that would be defined as cost function divided by X. Cost function is 40X plus 300 divided by X. That is your average cost function. Now they are saying evaluate average cost at 5. So you have to find average cost for cleaning 5 houses. That would be 40 times 5 plus 300 divided by 5, which would be 200 plus 300 by 5, 500 by 5, which is 100. So average cost of cleaning 5 houses is $100. Let's find average cost of 20 houses. So similarly, you can find this. So using 20 in place of X in the same formula, you can calculate this. This would come to be 55. On the same terms, if you calculate average cost of cleaning 30 houses, this would come to be 50, and average cost of 100 houses will come to be 43. So you see what's happening here. as you are increasing number of houses, the average cost cleaning per house is going down. That is what we define the average cost of house to be. Now, the cleaning service can realistically make a maximum of 160 calls per month. That means that on the realistic level, they cannot clean an infinite number of houses, right? So there is a limit to it. Maximum number of houses they can clean in a month is 160. However, if the number of calls are unlimited, what value would the average cost approach? So that is the application of asymptotes. Let's check the function one more time. So we have the average cost function to be x plus 300 divided by x. Let's try to plot this function on the desmos.com. You can try it on the calculator. 300 divided by x. So let's look at the function. So do not look at the left hand side branch. Why? Because x here is the number of houses cleaned. They cannot clean negative number of houses. So we have to say that x is more than 0. We are only gonna look at your positive x-axis. That means the first quadrant, right? Now see, the average cost of cleaning the houses is going down as we are going down. Now let's look at the function one more time. We have, this is the function. This is a rational function. If I have to find the horizontal asymptote, how will I do it? The degree of numerator, which is n, is 1. The degree of denominator, which is m, is equal to 1. The degrees are same. That means the horizontal asymptote is y is equal to an by bm. An is 40, bm is 1. So that is equal to 40. So that means y is equal to 40 is your horizontal asymptote. Let's draw it on our Desmos too. So we have y equal to 40. So you see how that is your horizontal asymptote. So what we are trying to answer here is the application problem where it asked, however, if the number of house calls were unlimited, what value would the average cost approach? So average cost is going down as we are increasing the number of houses. So you notice once it is past 150, you are seeing the cost is almost approaching to 40. That means average cost will approach $40 as x approaches to infinity. That is what it context means, that the final average cost will not go below $40. Average cost will not go below $40. That is the lowest it is going.